ready. He turns on the rubber, the 2-2 home. Swing and a miss, he struck him out. The 2013 Red Sox are the world champions and Boston strong.
In 2013, the Boston Red Sox won the World Series. But that success would not last. In 2014 and 2015, the Red Sox finished last in the AL East division. However, they came back to finish first in the division in 2016 and 2017. Every year, baseball teams fluctuate in performance. But what explains that fluctuation? In this video, we'll look at the regression method, a statistical tool that can help us attempt to understand what explains the changes in a team's performance year by year. This video will serve as an introduction to regression, and subsequent videos will dive into the specifics of the method and the code used to perform a linear regression. Regression analysis is a statistical technique that lets one find the relationship between the dependent variable y, also known as the response variable, and the independent variable x, also known as the explanatory variable. Regression is fundamentally about explaining the dependent variable. And in regression, we can say that the explanatory variable explains the response variable. And sometimes there will be multiple explanatory variables in multivariable regression. But single variable linear regression, which we'll use in this example, is based around the idea of creating a regression line, which describes how the response variable changes as the explanatory variable changes. This line can be described with the linear equation y equals mx plus b. We can begin by using the number of runs that the Red Sox scored in a season as our first explanatory variable, and we can graph that against the number of games that the Red Sox won in the same season. Runs should explain wins to a significant degree. In fact, I'd guess that the number of runs that the Red Sox score in a season will explain about half of the number of games that they win, with the number of runs that they allow accounting for the other half. Next, we can draw a regression line for that graph that best represents the data. The Python program used to create the regression line uses the ordinary least squares, or OLS method, to identify the best regression line for the dataset. We'll explore how that method works in the next video. After drawing the graph, we can use a Python program to determine the r-squared value of the trend line. The formal definition of r-squared is the fraction by which the variance of the errors is less than the variance of the dependent variable. Essentially, the r-squared value is a measure of how well the regression model explains the dataset. So, an r-squared value of 100% would mean that the model perfectly encapsulates the data, as it explains all of the variation that the data contains. The r-squared value of our first regression model is 0.453. This means that the number of runs the Red Sox score explains about 45% of the variation in the games that they win. In this spreadsheet, we can look at the r-squared for various hitting statistics. And you can see that some statistics explain more of the Red Sox wins than others. For example, on-base percentage is an r-squared of 0.402, or about 40%, while batting average is an r-squared of about 28%. So on-base percentage explains a lot more of the number of games that the Red Sox win than batting average. Runs tends to be the best metric in terms of hitting statistics, and I guess that would make sense given that a team has to score runs to win. We can also see that some statistics have a very low r-squared value. For example, the number of triples that the Red Sox hit has an r-squared value of essentially 0. And I think that's an effect of how few triples occur in baseball. But also, the number of times that the Red Sox runners were caught stealing has a very low r-squared value as well. And that just says that the number of times that the Red Sox runners were caught stealing does not do a good job of explaining the number of games that the Red Sox win in a season. If you want to learn more about regression, make sure to check out the description where there'll be some other resources. And thanks for watching.